Hi, I'm John Ambrose Fleming, and today I'm going to talk to you a little bit about my life. Well, the first thing is that I was born in Lancaster, England in 1849. I proved to be a really brilliant young man because I delivered my first electromagnetism lecture at the age of 13. Then, at the age of 16, at the University of London, where in 1870 I achieved my university graduation with a great brilliance despite the economic difficulties that I had, which forced me to perform jobs that allowed me to obtain economic resources to finance my studies. I am a British physics and engineer, and I invented the thermomic bell. I studied electricity and magnetism at the University College, the Royal College in London, and the University of Cambridge, where I was a disciple of Maxwell. In 1979, I received the degree of doctor and continued to work at the Cambridge Laboratory in 1881, that was when I obtained the chair for physics and mathematics at the University of Nottingham. Oh, sorry, is that I love my mustache. But well, let's continue. Well, I was appointed as Professor of Electrical Technology at the University of College London in 1885 and at the University of London in 1910. You want to hear some anecdote? Well, it's that my notes explained in my lessons are really quickly, so it is practically impossible for my students to take notes. I received several awards through my life. Well, let's talk about them. First, it was the Gold Albert Medal from the Royal Society of Arts. Then, it was the Friday Medal from the Institution of Electrical Engineers. And then, it was the Franklin Medal from the Institution of, let me remember, it was Philadelphia. And in 1929, the appointment of knights gave me the treatment of Sir. Later, do you want to know what happened? Well, that's a good thing. In 1905, I patented the Fleming bell that served as a rectifying diode. Well, it was the year 1904, and as a result of these investigations, I discovered that by placing another independent electrode inside the infrared bulb and somewhat far from the filament, I will put you an image of my drop here so you can understand a little bit better. Well, a circulation of electric current was established far from the filament, which in this case is the cathode, towards the new electrode, which in this case is the anode, through an external circuit. And also, I invented the diode electric veil, which paved the way from later advances in modern electronics. Now let's move on with my electronic veil. I will put you an image here so you can understand the information that I will tell you in continuation. Well, the letter A, as you can see, is the intranscendent lamp filament as the cathode function. The letter B in this model is the new electrode in function of anode. The number 1, which is here in the battery, is exactly the battery for filament engagement and heating. The number 2, which you can see in the batteries right here, is the battery for supplying the external circuit of the diode veil. The number 3, which is located between the letter B and the letter A, is the electronic current that is established far from the filament, which I explained you before, that is the cathode, towards the anode. And the number 4, which is upwards, the number 2, is the galvanometer that detects the passage of electric current through external circuit of the veil. Well, my device began the age of electronics. Well, I designed the power plant that Marconi used to transmit the first radio message across the Atlantic. I devised the left-hand rule for motors and the right-hand rule for new generators to help myself and my students to understand better the relationship governing the directions of the electric current, the electric field, and force. I came up for the idea for the thermomic bell on October 1904 and patented in the following month.